Hello everybody, and once again welcome to Pankaj's Echelon tutorials. And in this today's session we are going to deal with Igcse, and this is for the 10th grade, and the subject is mathematics, international mathematics of course, but in this session I'm going to go into the basics only. Okay, the basics of the international mathematics, and the topics that I've chosen is numbers, then operation with numbers, and using numbers. These are the first three chapters, okay, which I'm going to concentrate on. Okay, so in the basic mathematics you have to study all these numbers, operation with numbers, and using numbers. So I've chosen some few concepts and problems based on those concepts. Okay, so let us get started with it. To get started with, the very first concept that I'm going to deal with is something called prime factors, and how to find the prime factors of a given number. Okay, so there's a method called prime factorization method, and this method name is tree diagram. So using this tree diagram you can do prime factorization method and find out the prime factors of a given number. So first I'm going to do some problems based on that. So at question number 1, express each number as prime factors product. Okay, so the first one is a part of this question is 120. So how you have to do this? You have to write 120 over here and make a branch like this. Okay, now you all know that the very first prime number and the lowest prime number is 2. So we have to start with 2. So write a 2 over here. Okay, and 120 divided by 2 is how much? That you write over here. So 120 divided by 2 is 60. So 60 you have to write on the other side of the branch. Then same thing you do with 60. Now 60 is again divisible by 2. So write a 2 over here, and 60 divided by 2 will be 30, that you write over here. Again 30 is divisible by 2. So I'll write a 2 over here, and 30 divided by 2 is 15. So I'll write a 15 over here. Now what happens? This 15 is not divisible by 2. So you have to go to the next prime number bigger than 2. So that is 3. So divide this 15 by 3. If it is dividing, fine. You can write a 3 over here, and 15 divided by 3 will be 5. Okay. Now 5 is not divisible by 2, 3. So go to the next one, and the next prime number is 5. So divide this by 5 and you will get a 1 over here. Okay. So this way you have to go proceed with the factorization in the tree diagram method this way till you get this 1 at the end. Okay. Once you get the 1 at the end on the right hand side branch, you know all the numbers on the left hand side are nothing but the prime factors. Okay. So you can see that there are 1, 2, 3. 3 2's are there. Okay, so 2 raised to 3 will be the prime factor. Multiplied by 1, 3 is there. So that 3 will also be a factor. And there's 1, 5. So 5 will also be a factor. So prime factors of 120 will be 2 raised to 3 into 3 into 5. Okay, 2 raised to 3 because there are 3 2's over here. 3 2's if you multiply can be written as 2 raised to 3. Here you have only 1 3, so it will be into 3 raised to 1. 1 5, so into 5 raised to 1. Okay, no need of writing that 1 on top of 3 and 5. So this is how you do prime factorization of 120. On the same lines, you can do the prime factorization of 252. So start with 252, right? 252 over here. Now since 252 is divisible by 2, we'll start with the 2. So 252 divided by 2, you write it over here and you get 126, that you will write here. 126 divided by 2, you write 2 over here, is 63. So write 63 over here. Now 63 is not divisible by 2. So go for the next one. The next one is 3. So 63 divided by 3, you write 3 over here. And here you will get the answer as 21. So 21 you write over here. Then 21 divided by 3 will be 7. And 7 divided by 1. 7 divided by 7 will be 1. So you get a 1 over here. So here also, now you have to stop because you have reached 1 on the right hand side branch. Now all the numbers on the left hand side branch are the prime factors. So you have how many 2's? You have 2 2's and you have 2 3's and you have 1 7. So the prime factors of 252 will be 2 square into 3 square into 7. Right? So these are the prime factors of 252. Same way for 600. Write a 600 over here and it is divisible by 2. So start with a 2. 600 divided by 2 will be 300. 300 divided by 2 will be 150. 150 divided by 2 will be 75. 75 is not divisible by 2. So go to the next one, that is 3. So 75 divided by 3 is 25. And 25 again is not divisible by 3. So go to the next one. So next is 5. So 25 divided by 5 will be 5. And 5, this 5 divided by 5 will give you this one. Okay. So you see that on the right hand side you get a 1. At the end of the right hand side branch you get 1. So these are the prime factors on the left hand side. So how many 2's you have? 1, 2, 3. 3 2's you have. So 2 raised to 3. Then you have 5. Okay, how many 5 you have? You have 2 5. So 5 square, 5 raised to 2. And you have only a single 3. So into 3 raised to 1. Okay, so these are the prime factors. 2 raised to 3 into 5 raised to 2 into 3. Same way, 728. 728, you start with 2. So 728 divided by 2 will be 364. 364 divided by 2 will be 182. 182 divided by 2 will be 91. 91 divided by, now 91 is directly divisible by 7, right? Because 91 cannot be divided by 2, 3, 5 also it is not divisible. So by 7 you try. So 7 if you divide, 91 divided by 7 you get 13. So write 7 over here, 13 over here. Now 13 itself is a prime number. So 13 will be divided by 13. We will get a 1 over here. So here we get a 1 and so we can stop it. Okay. Now on the left hand side you have got the prime factor. So how many 2's are there? 1, 2, 3. 3 2's. So 2 raised to 3. How many 7 are there? 1. So into 7. How many 13? 1. So into 13. So these are the prime factors. Okay, 2 raised to 3 into 7 into 13. Last is 1980. 1980 you divide by 2, you get 990. 990 again you divide by 2, you get 495. Now 495 being a number which is not divisible by 2, so you have to move to the next prime number, that is 3. So if you divide by 3, you will get 165. Now 165 again divide by 3 will give you 55. Now 55 is not divisible by 3. So you have to move to the next prime number. So that is 5. So divide by 5 will give you 11. 11 being a prime number, 11 divided by 11 will give you 1 over here. So these are the prime factors. 2 raised to 2 into 3 raised to 2 into 5 into 11. So this is the answer. 2 raised to 2 into 3 raised to 2 into 5 into 11. So that was how you have to do prime factorization by tree method. Now, this is question number 2. Copy and complete the factor tree. Now, this is the red is the answer actually written, okay? But the yellow diagram is something that you have to fill, okay? So, such diagrams, for factorization, factor tree, if you want to fill up, you have to start from the base. So, here 2 and 3 is given. So, 2 into 3 is what that you have to write in this first circle. So 2 into 3 is 6. So I have written 6 in red. So 6 is the answer. Okay. Then you have 13 over here. So 13 into 6 will be how much? So 13 into 6 has to be 78. So I'll write 78 over here. Then 78 into 2 is how much? 156. So I'll write 156 over here. So this is how you have to complete the table of a factor tree. Okay. If there is some places vacant given in the question. Okay. Now starting for B, now at the bottom you can see 5 and 7 is given. So 7 into 5 will be 35. So here you have to write 35. Then 35 into 11 is how much? 385. So that you will write here. And 385 into 5 is 1925. So that you are going to write here. Okay. C1. 2 into 3 is 6. So I'll write a 6 over here. 1 into 7 is 7. So I'll write a 7 over here. Now these two circles I'll multiply. 6 into 7 is 42. So 42 I'll write here. And 42 and this one, 42 into 1 will be 42. So that I'll write it over here. That was C. Now D question. Now these red ones are the vacant place that you have to fill. Okay. So how I got the answers that I'm telling you. So 2 into 3 I will do. I'll get 2 into 3 6. So I'll write a 6 over here. Then 3 into 7 is 21. So 21 I'll write here. Then I'll multiply this 21 and 6. 21 into 6 is 126. So I'll write 126 over here. Then 126 I'll multiply with this 3 and I'll get 378. So that I'm going to write here. That way all my circles will be filled up. So this is how we have to do this second type of a question where you have to fill the vacant places, and this is based on the factor tree. Okay. So that's all about prime factorization and the factor tree. Now let us try to do this type of question. Question number 3. Express the following in index number. Okay, index number, or you can say exponent form. Right. Now the first one is A part is 4 into 4 into 4. Now 4 into 4 into 4 can be written in index form as 4 is to 3. Okay, it's very simple because you can see 3 4s that are multiplied. So 4 you have to write, and on the top how many times it is multiplied, that you have to write. So 4 is to 3 is the answer for this. Here you can see 2 is multiplied 3 times, so it will be 2 raised to 3. and 3 is multiplied here 1, 2, 3, 4 times. So it will be 3 raised to 4. So 2 raised to 3 into 3 raised to 4. This is the index number. Okay, index number will be some base raised to some index. Okay. Now here in this number you can see that 2 is 1, 2, 3 times. So I'll write 2 raised to 3. Then 3 is 1, 2, 3 times. So again 3 raised to 3. And then 5 is how many times? 1, 2, 2 times. So it will be 5 into 5 raised to 2. And then what is remaining? 13 is remaining. 13 is 2 times. Okay, so 13 raised to 2. So in the index form, this number can be written as 2 cube into 3 cube into 5 square into 13 square. Going to next question, question number 4. Now there are some number given to you, 0.35, 1 by 2, root 5, 5 by 3, 27, 36, 43, 51 and 81. Now these numbers, what you have to do is list the following from the above. So you have to take these numbers from these given numbers and you have to put in this appropriate category. Okay. So there are some A to F categories given: square numbers, cube numbers, triangle numbers, prime numbers, irrational numbers, and rational numbers. Okay. So one by one, you have to pick up the numbers from here and put in the appropriate category. Now 0.35. 0.35, you cannot put it in square numbers, you cannot put it in cube numbers, triangle numbers you cannot put, prime number no, irrational number no, because it's a 0.35 is a terminating decimal, so it will not come in irrational number. In irrational number you will get non-terminating, non-recurring only. Okay. And last column remaining is rational number, so it will come in rational number column. So 0.35 will come in the rational number column. 1 by 2, again 1 by 2 will come in the rational number column because 1 by 2 is a fraction. Fraction will come in rational number. Root 5 is a square root sign you can see, but inside you can see a number which is not a perfect square. So under a radical sign, if you have a non-perfect number, then it is an irrational number. So root 5 you will put in irrational number category. Pi by 3, because you can see a number, you can see that pi, okay, pi is an irrational number, and irrational number multiplied by any other number or divided by any other number or added or subtracted by any other number will give you a irrational number only. So here you can see that pi is an irrational number which is divided by 3, so the resultant will be also a irrational number. So pi by 3 I will put in the irrational number column. 27. 27 I cannot put it in square number because 27 is not square of anything. Cube number, yes, I can put 27 in a cube number because 27 is the cube of 3. 3 into 3 into 3 is 27, right? 36, I can put it in the square number category also, and I can put it in the triangle number category also. But 36, if I put it in square number category, then this triangle number category will remain vacant because you have only one number which is a triangle number. Now, what are these triangle numbers, that I will tell you right now so that you'll understand why 36 has been put into triangle number. Now, what are triangle numbers, Triangle numbers are, now just consider this pattern. Now, this is what you can say, one uh, dot, okay? Now, if you take two dots, okay, so uh, you can put two dots this way, right? Three dot you can put this way, two dots and three dot, right? So one number dot, one is a triangle number, two is not a triangle number because two dots cannot be arranged in the form of a triangle, right? But three dots you can arrange in the form of a triangle. So three you can take as a triangle number. After three, if you take four, okay, so if you take 3 over here, you will take uh, two dots, okay, and here we will take one dot, right? So this happens to be a triangle, okay, 3, 3, 3. So this is also, now how many dots are there total? 1, 2, 3, 4, 5, and 6. So this is also a triangle number because it can be arranged in the form of triangle. So 1, 3, 3, yeah, 6, and then next is what? Next can be like this is 3, right? So I'll put now 4 dots. 1, 2, 3, 4. Now this way 4 and this way also you have to put 4. Okay, so 1, 2, 3 and 4. And this way also you put 4. So 1, 2, 3 and 4. So can you see this is 4 dots, 4 dots and 4 dots. The sides are made from 4 dots. Okay. So you will be able to make a triangle. And here now you will be putting this many dots, right? So here there are 4 dots, 1, 2, 3, 4. Here there are 3 dots, okay? This is something not correct. One second. 4 dots over here. This will be 4 dots. Okay. And again here, this is 4 dots. So here I'll be putting 3 dots. Okay. And here I'll be putting 2 dots. This central dot will not be there. 2 dots and 1 dot. Okay. So 4, 3, 2, and 1. That way it goes. Okay. 4, 3, 2, and 1. As you go up 1 dot, you have to reduce. So 4, 3, 2, and 1. And sideways, there should be all equal number of dots. So 4 dot over here, 4 over here, 4 over here. And you get a triangle. Okay. Now, what is the total number of dots? It is 4 plus 3, 7, 7 plus 2, 9, and plus 1, 10. So 10 is also a triangle number. So these type of numbers, okay, which can form triangles are known as triangle number, isn't it? Now 36 is a triangle number or not. If you want to find out, then what you'll do now, see, this is 1, 3, 6, 10. Okay, now after 10, 10 we got by arranging 4 dots. Okay, now if we arrange 5 dots, let us see what we are getting. 1, 2, 3, 4, 5. Now this way also I'll put 5 dots. 1, 2, 3, 4, and 5. Okay, and this way also 5. 1, 2, 3, 4, and 5. Okay, now this is 5. So on the top I should have 4 dots. So 1, 2, 3, 4. Here I'll have 3 dots. So if you add these dots, what you should get. This is 5 dots. So 5 dots at the bottom row, 5 plus at the top of that will be 4 plus 3 plus 2 plus 1. Okay. Now check this. This will be a triangle number. So 5 plus 4 is 9. 9 plus 3 is 12. 12 plus 2 is 12, 13, 14. 14 plus 1 is 15. So the next one will be 15. Okay. This way you have to do. Now if you want to find the next triangle number, so this was corresponding to 5 base. Okay. Now you do 6. So it will be plus 6 you do. Right. Now this is 15. 15 plus 6 will be how much? 21. So next will be 21. Then here you add 7. So till here it was 21. 21 plus 7 is how much? 21 plus 7 is 28. Right? That way you have to go on. Here you add 8. 21 plus 8. 21 plus 8 is 8 plus 8, 16. And 1 carry, 2 plus 1, 3. So 36 you are getting. So 36 is a number which is a triangle number. So from this 36, I am going to put into this triangle category. Okay. See, if I put this 36 in the square category, nothing wrong. 36 is a square number. But then this triangle number ka category, there is no other number which comes in the triangle number category. And this category will remain vacant. Okay. So that is why I have kept this 36 in triangle number. And 36 is a triangle number. This is the way you have to understand. This is the way you should write all the triangle numbers. Okay, so 1, 3, 6, 10, 15, 21, 28, and then 36. All these are triangle numbers. I hope you must have understood what are triangle numbers by now. Okay, so 36 is a triangle number. The next one is 43. Now 43 will come in prime number because that is a prime number. I will put 43 in the prime number column. Now 51. 51 is what? 51 can be written as a what, in which category it will come. It will come in rational number. Okay, because 51 is a pure number, natural number, and all natural numbers are this thing. So 51 will come in only rational number. It cannot come in either triangle number, nor cube number, nor square number. Okay, so I have put it in the rational number category. And last is 81. Now 81 can come in the square column because square number category, because 9 square is 81. So 81 I have put over here. So this way all the numbers I have utilized and put in this categories. This is how you have to deal with this particular question, right? Chalo, shall we move to the next one? Fifth question. Find the HCF of the following. Now 84 and 72 ka HCF you have to find out. 540 and 360 ka HCF, and these two numbers ka HCF. Now this particular question from HCF, LCM, all that up to 5th to I think 10th. Okay. these questions, I'll be doing in the next video. So today we did some 5 questions. Okay. And that's all for today. And in the next video, I'll be dealing with the remaining questions. Okay. So if you happen to like my video, please subscribe my channel. And that's all for today. Bye.